Hi guys, Brad here from Heinz Stormwater team. Another episode of Stormwater TV, you could say. I'm going to share with you a really cool project that we've just supplied and commissioned this morning. So I'm in Nelson, I'm at the Marina, not a bad place to hang out. As you know, my last name is Tiller, so I do love my boats. And behind me here is the stormwater treatment system, which I'm going to give you a quick overview on what we designed and essentially supplied in partnership with Beca, and Nelson City Council, contractors Higgins, and subcontractors Asphalt Construction. So marinas are notoriously challenging sites, challenging environments to treat. There's obviously large surface area, so this was actually gravel, and it's been asphalted, so there's a large, I think it's 1,500 square meters, so that's going to generate a lot of rainfall runoff, which needs to be treated, and also the wash water or the processed water. So it's actually commercial, if not some semi-industrial runoff actually, so we need to sort of separate those flows. Really what happens on marina hard stands is well, a number of things. Obviously water blasting and wet sanding. So the anti-foul paint on boats has a high copper load. It's sort of chemicals, it's almost sort of fungicide paint, if you will, which gets sanded off and rinsed onto the hard stand, where it would generally go to the ocean. Okay, so there's a high pigment and sort of loading, and also for those of you that know boats, there's always a sort of bilge water, sort of hydrocarbons and diesel and emulsified soaps and things like that, which can end up in the stormwater. So it really does have a very high copper loading predominantly. So that's really trade waste. So in this situation, the trade waste runoff goes to this sand and peat filter, and the stormwater goes to the larger sand filter. Okay, so this one discharges to the trade waste network, and this one discharges to the stormwater network, which ends up right there. Okay, so that's 20 meters away to the ocean. So stormwater comes into the Enviro valve first of all. Heinz Enviro valve have been around for donkey's years. Pretty robust system that'll separate the stormwater from the sewer. How it does that is there's this control panel. Okay, so that basically is a pressure switch which monitors the pressure. So when there's a turning on of a water blaster over where you saw earlier, it's going to tell the Enviro valve, okay, send a signal to the solenoid and open to the sewer, which I think is happening now. And then that might happen on a weekday, like where it's not raining. And then on top of the roof there's a rain switch, which measures the first 10 millimeters of rain, and then does the same process, sends a signal to the solenoid to open to the stormwater. So that's a sort of a foolproof, user-friendly system, which is automatic, and it takes into consideration the first flush and separates the flow. So from the Enviro valve, it goes to both the pump stations. So this is these are two 1800 diameter manholes which we supplied, designed. This one's the stormwater. So inside there's essentially a 4-bay, which is going to provide a high degree of settlement. So there's a wet sump there, and all the stormwater, all the what's with the trade waste, is going to pass through the smart sponge filter packs. So those are going to absorb the hydrocarbons. So we really want to prevent any hydrocarbons from contaminating the sand and peat media. Okay, it's best to keep them separate. So that's also going to remove a lot of the finer silt, sort of down to the 20 micron range. And then there's a pump station. Okay, so the pump is going to lift the pre-treated stormwater or the trade waste water to the sand and peat filters. Okay, so this one was designed to hold 10 cubes, slightly smaller, treat the trade waste, and this is a TP10 designed structure. So we've got the ratios of the 4-bay settling and the actual treatment bay here. So there's you can see the colour of the water is actually blue, which is really coming off the pigment from the anti-foul paint boats that you've just seen being sanded. So it goes through the weir and it sort of evenly disperses or cascades into the treatment media, which so that's designed to fill. And then there's the high level bypass here, so that'll just discharge to the sewer network. So inside we've supplied it with a standard 50-50 blend of a fine grade sand and peat. Okay, so that's really nothing new. Again, it's been around in the industry for a long time. So the peat offers the absorption of the contaminants and really the sort of the bioremediation or absorption, and the sand offers the filtration. Then there's also this the crushed mussel shells. There's been a lot of talk about crushed mussel shell the last few years. University of Canterbury, Francis and Ash and Tom have been leaders in that field, done a lot of papers on it. It's been used in marinas before. It probably has a higher level of removal efficiencies, some would say, also a much higher hydraulic conductivity. Okay, so it's all because of aside of the calcareous nature of the material, there's a high organic content in the material, which seems to remove heavy metals to a much higher degree, but it also aids in that pH buffering, so you get a lot more precipitation. So that's something that we might look to in the future, depending on the performance. So that's really the system. It's designed to work, very low maintenance, and no user input really. It should run automatically, take into account activities when there's water blasting, goes through the enviro valve, through the pump station, or when there's rain, it goes through the other stormwater pump station and into the larger system and discharges to the street via a wire stop, actually, because the high tide preventing the seawater ingress up the line. So this is a really cool system. These are quite large. These were made in Christchurch. This one weighs about 28 tonnes, and this one weighs, I think, 22 tonnes. So these are made in a high Dura blend concrete for the marine environment, and also built to last. Okay, so 100-year design life. Excellent design partnership and process with Aoife, Philip and Tim at Beca. I really enjoyed the dialogue, and also John Louis at Nelson City Council, awesome project management, but also Jarrod and Jason at Asphalt Construction, and Jamie Higgins at Jamie McGookin at Higgins. Yeah, really cool, project. Yeah, we did it, supplied it in a hurry, and yeah, as a result, we're going to have much cleaner runoff from this large catchment area, and ultimately the marine environment is going to be a lot more protected. Okay, that's all, guys. Over and out.